Okay, in scale 5, we are looking at graphing a couple functions. One's got an exponential in it, one's got a logarithmic in it. So we're going to go through the first example in this video, and then we'll work through the second one in the next one. So we are starting with f of x equals x squared times e to the x. Now this has something that's maybe a bit beyond the scope of this course and figuring out, does this thing actually have a horizontal asymptote or not? So there's y equals e to the x. There's x squared. So we have these two conflicting ideas. E to the x is on the left side, it's going to 0, and as x gets really negative, x squared is going to infinity. So we have something that's going to infinity multiplying by something that's going to 0. So this is again kind of one of these indeterminate forms, just like our 0 over 0 limits from the first cycle, because we have two conflicting ideas. We don't know which one's going to win, because anything times infinity should be infinity, but anything times 0 should be 0, so we're not sure what wins. So solving like algebraically whether or not overall this is going to be a horizontal asymptote still at 0, or whether the x squared is going to win and it's going to go off to infinity on that side. A bit beyond this high school calculus, you need something called L'Hopital's rule to prove that. So instead what we're going to do is we're just going to plug in a really small, like very negative number, so like f at negative 1,000, let's say, and we'll see what's going on. So we have negative 1,000 squared e to the negative 1,000. And negative 1,000 squared is a big number, e to negative 1,000, a very small number. So small, in fact, this calculator is telling me it is, in fact, just 0, which is not quite true. Maybe I'll go with 100. Yeah, so e to 100 is something times 10 to the negative 44 on my calculator. So 0 point and then 43 zeros before we get the first actual digit. 100 squared is just going to be like just that many zeros. So that's going to come nowhere as close to canceling out the 43 leading zeros in the other number. So this is, a basically 0. We're going to get 0 point and then like 40 zeros before we get to our first digit. So all of that is a roundabout way of saying is this graph is going to have a horizontal asymptote of y equals 0 on the left still, because the e is so much closer to 0 than the x squared is to infinity. So again, that's not something that I'd ask you to do on the test. If I give you something like this on the test, I'll tell you whether or not the horizontal asymptote remains or not. But basically, e is going to beat any polynomial is sort of what's going to happen if you're multiplying a polynomial by e. The e will win every single time. So with that, now we can find our no vertical asymptotes. We're never dividing by 0. So we're going to or we don't have any logarithms that would give us vertical asymptotes. We're going to find our x-intercepts and our y-intercepts. So for x-intercept, we get 0 equals x squared times e to the x. So we get one answer when x is 0, and e to the x is never 0. So we get no solutions from there. So this graph goes through the origin. It's got a horizontal asymptote on the left side. That's where we're at so far. Now let's go on to the derivative. So we're going to need a product rule because we've got two things multiplied. So we're going to do f prime g plus g prime f, something like that. And then we're going to common factor that out. So I get e to the x times x squared plus 2x, if I write them in the other order to be fancy, which further factors into e to the x times x plus 2. So there we go. So that gives us, again, no solutions from e to the x. That's never 0. X equals 0 or x equals negative 2 are the spots where the derivative is 0. So we get minus infinity, 0. Let's do this in the right order. -2, 0, infinity. And for factors, we have e to the x, which is always positive, x, which is negative, and then positive, and x plus 2, which is negative, and switches at -2 there. So overall, our derivative is positive, then negative, then positive. Both of these points have horizontal tangents, where, because the derivative is 0 there, this one goes from increasing, flattens, decreasing, so we have a horizontal tangent max. The other one decreasing, flattens, increases. That's a horizontal tangent minimum. 0 is the origin, 0, 0, we already found that point. For -2, we're going to plug -2 in to get our y value, so we'll get -2 e to the -2. E to the... And I get 0.54 when I plug that in, so there we have that. So now I'm going to move on and find my second derivative. So the unfactored version, I think, is the easier version to get the second derivative from. So I'm going to be looking at that. The second derivative, again, we're going to do f prime. So f is e to the x, f prime is e to the x, times g, plus g primed, which will be 2x plus 2, times f, which is e to the x. And we get the same sort of thing happening. We can factor out an e to the x, and we're left with x squared. There's going to be 2 plus 2x's, so plus 4x, and then a plus 2 in the brackets. So we have that, that quadratic at the end there. It does not factor. So let's just see what we can do with that. X is going to be -4 plus or minus the square root of 16 minus 4 times 1 times 2, all over 2 times 1. -4 plus or minus the square root of 8, that looks like to me, over 2. So we're going to get two answers here. -3.4 or -0.59, 0.6. We're graphing, so we can just go to one decimal place. We don't have to be too accurate here. So there we have it. So we can make a factor table with those two things. And our second derivative had that e to the x out front, which is always positive. Again, this quadratic does not factor, so I'm not going to pretend it does. I'll write it all as one thing. And then I know since it opens up, it's negative between its x-intercepts. So our second derivative is positive, then negative, then positive. So we get concave up, then down, then up. It switches twice, so these are both POIs. So we just need to get y values for those as well, 3.4. So we're going to do e to the -3.4 times 3.4 squared. I got 0.4 basically there, 385. And this one -0.6. So we're going to do e to the -0.6 times 0.6 squared. 0.2, basically 197. So there we go. We've got all of our key points. So I'm going to make a summary table. So if I look at my two tables, I can kind of barely see that first derivative one up there. My numbers are -3.4, -2, -0.6, and 0. Let me do this where I have more room. Our first derivative starts out positive. It's positive all the way up to the -2. It's negative between -2 and 0, and then it's positive again after 0 is what we had. Our second derivative is negative between -3.4 and 0.6, and positive outside of there. So overall, our shape, increasing concave up, increasing concave down, decreasing concave down, decreasing concave up, increasing concave up. So those are our various shapes. So our points, we have the origin was one of them, and that was a horizontal tangent. So I'll put my dotted line in there. -2 was -0.54, I think. Sorry, I think it was 54, not 64. Can't read my own writing. Can you imagine not being able to read my own writing? So 0.54 for -2, -3.4. So there's -3.4 and 0.4, so I got to be a bit below that somewhere. There's my 1 point of inflection, and -0.6 and -0.2, so wonderfully to scale, something like that. And we have horizontal tangent there as well. That's going to be our max. And remember, we do have this horizontal asymptote out that side on the left side. So I'm going to start with this shape. I'm going to hit that point of inflection there. We're going to switch now to this shape and flatten out at our max. Probably could have drawn these spread out a bit more vertically. I didn't realize didn't really think that one out. And then we're going to switch to this shape here. Switch to this shape, flatten out at the origin, and go off to infinity. So something like that for that graph. And then we've got the horizontal asymptote out this side. So there we go. There's our pretty picture for the first one. So again, I'll do the second one.